Welcome everyone, this is Mr. Mayer, and in this video we will discuss reflectional symmetry specifically for regular polygons. So just to recap, remember the number of lines of reflectional symmetry equals the number of sides of the regular polygon. So some important things to realize. Regular, first of all, regular, this means all congruent sides, all congruent angles. What this is saying is that the number of lines, the number of times that we're going to have reflectional symmetry is equal to the number of sides for that regular polygon. Okay, but again guys, it has to be regular. If it's not a regular figure, this is not going to be true. So let's go ahead and take a look at GeoGebra in order to make this happen. Here I created a regular pentagon. Again, it's not labeled here. I'm telling you it's regular, so therefore it means all the angles are congruent, all of the sides are congruent. Remember a pentagon? Pentagon has 1, 2, 3, 4, 5 sides. So we're going to go ahead and find a place. Remember, we're doing reflectional symmetry, a place where we can fold our figure so that the two halves land directly on top of each other. They overlap completely. There is no excess. There's no extra hanging over. All right. So the first thing to do that, a good way to understand where to start is you always want to fold your figure kind of halfway or in the middle. So if I start from point M, I'm going to go all the way down, but it has to be specifically exactly right in the middle between O and K. Again, what's nice with GeoGebra is it allows me to go ahead and find the exact middle point. This is P, which is the midpoint. So at this time, I'm going to go ahead and connect M with P, and this should be a line of reflection to create some reflectional symmetry. Well, how can we be sure? So what we're going to do right now is we're going to take a point that's on the left side. Let's make sure it overlaps completely with a point on the right side. So if I choose point N, it should go overlap with point L. Let's see if it's true. I chose point N. I'm going to choose it to overlap or to reflect over this line, and notice N prime, or the new N, is directly on top of L. So that was perfect. Let's just double check with O, make sure O lands on top of the K, and it sure did. So here's my O prime. Now a question I frequently get is, Mr. Mayer, what's going to happen if I choose point M? Where would M go? Well, go ahead and choose it. If I pick point M and tell it to reflect over line MP, watch where it goes. Hey, it stayed exactly in the same place. And that is going to be true every time that you choose a point that is directly on top or a part of this line. Okay, it's going to stay exactly in the same place. So let's go ahead and, is this going to be the only line of reflection to create reflectional symmetry? In this example, since it is a regular pentagon, we know there's supposed to be 5 lines. So it's not just through point M that I can make a folding line. I can also create a folding line through every other vertex, every other corner. All right, so we're going to go ahead, let me get rid of our reflections. And I'm just going to go ahead and draw all the lines at one time for you. At this point, let's go ahead and count how many lines we have. We have 1, 2, 3, 4, 5. Should I keep going? No, I started at M. Oh, it's the same line. So there are 5. There are 5 lines for a regular pentagon. One last thing to bring up to you. Notice that all of your lines of reflection, they all intersect at a center point. This is always true for any lines of reflection that you're going to have. Okay, so that's a nice check to make sure you did it correctly. Thank you for tuning in, and hope to see you in the next video.